Hello and welcome to Software Uncut, a podcast for developers about building great products. Today, I'm excited to welcome Holly Cummins. Holly, thank you so much for joining us.
Oh, thank you for inviting me.
Great. Can you please just go ahead and introduce yourself?
Sure. So as of about 6 weeks ago, I work for Red Hat, and I'm a software engineer on the Quarkus team, a senior principal software engineer. But before that, I was with IBM for 20 years. And for the last 5 years that I was with IBM, I was a consultant in the IBM Garage. So our mission really was to help clients take advantage of the cloud. So I was working with a lot of clients at sort of various stages on their cloud journey, which was really good fun. And it also meant I got to see lots of success stories. And I also got to see lots of cases where maybe it hadn't gone quite right. And then, so then we were sort of brought in on a rescue mission. And that was very educational as well.
Microservices architecture is all the rage these days. But do you know what it really means and how to implement it to empower your teams to make the best decision for the problem at hand? On the Semaphore blog, you can learn about microservices and how to take advantage of features like test reports, on a repo, and Docker support to build, test, and deploy your microservice application at scale. Head over to semaphoreCI.com/blog for more information. And happy reading.
I guess one of the things that you saw in the garage to say is the, potentially some transitions to microservices and,
I think we're sort of at an interesting flux point with microservices where half of us are still trying to get to microservices and half of us have got to microservices and are now possibly on the way back. So, we're sort of, some of us are in the trough of disillusionment and some of us are still on the other side of the hype cycle. But certainly with microservices, it has become so popular and it's become almost a goal in itself. And that was one of the things that we saw was we talk to people and they'd say, okay, well, I want to go to microservices. And then we just sort of have to step back and say, okay, well, microservices aren't a goal in themselves. Your customers are never going to look at your website and go, look at all the beautiful microservices. What they care about is, is it flexible? Does it update to meet their needs? Does it actually meet their needs in the first place? Is it responsive? And so we sort of need to step back from the implementation detail to think about that higher level. Okay, what do people need from us? How do we actually do that? It may involve microservices or it may not. I think often the problem isn't that microservices were the wrong answer. It's just that microservices are an incomplete answer. And it's not like you can decompose your application into little bits and then all of your other problems go away. And so what we saw was there'd be that architectural decomposition, but all of the stuff around it would stay the same. And so we're going to microservices because we want to be able to respond to customer requirements faster, but our release board only meets every 6 months. Well, then that your release speed your release cadence is going to be once every 6 months. So it probably doesn't matter whether you have microservices or not. And maybe you want to work on fixing that bit first. Or we saw it as well, because handling the dependencies between microservices can be really hard. And because getting that confidence in the quality can be pretty hard. What some organizations did is they said, if these things release independently, trying to get adequate test coverage for that will be a nightmare. So what we'll do in order to make sure that we have adequate test coverage is we'll set our pipeline up so that we have one big pipeline that deploys all of our microservices at the same time. And so then you lose that benefit of independent deployability, which was one of the main things that, should be using microservices to achieve. And so then what's left really is that you've lost your compile time checking. You've lost all of that type safety and API safety. You've lost the things like guaranteed execution that you get with a monolith, but you still haven't gained any of the agility or independent deployability or sort of time-wise decoupling that you were maybe hoping for. I think it seems to organizations like they have two choices. So the first choice is that they don't spin everything up in their CI/CD pipeline. They don't test things together. And that seems like a huge risk because, we have all these dependent systems. If we don't test them together before throwing it out into the field, that's going to be bad. And so then in order to mitigate that risk, exactly as you say, they spin everything up, but then it's really fragile, it's really brittle, it's really slow. I think there is a third way that is not as widely used as it should be, and that's contract testing. So contract testing is a really nice sort of middle ground between unit tests and integration tests. So unit tests have the disadvantage, they have the advantage that they're really quick. They have the disadvantage that you bake all of your assumptions about your dependencies into your unit tests. And so if those assumptions are wrong, and usually what breaks systems is incorrect assumptions, then the build is green, you deploy, and then it fails in production, which isn't what you want. Or the alternative is the integration tests, which are really expensive, really slow, really fragile. You sometimes need to have a whole team just dedicated to try and keep these integration tests kind of alive and kind of working. So what contract tests do is they're sort of in the middle. They have the build time characteristics of a unit test, so they're really fast to spin up. But what they do is they sort of straddle that chasm between a component and its dependencies. So the idea is that you make a little JSON file and it says what I expect my dependency to do. And then I share that JSON file to the team which is managing my dependency. And then on my side, it acts as a mock. So instead of using WireMock or something like that, I can just use my contract test provider and it will mock up all my dependencies. But with a normal mock, if my dependency changes and I don't think to update my mock, we're back in that. My tests are green and it's all broken. On the other side, so on the producer side, they use that same contract and it acts as a functional test. So it does the same thing as something like rest assured. And so both teams are getting something out of that testing. And because it's making a connection between the two teams, it does give you that confidence that things are actually going to work together in the field, but without the expense of integration tests.
What are your thoughts on monorepo approach and keeping, all those services in one Git repository? Kind of a very low level detail, but can end up with huge productivity changes.
Monorepo is something that I haven't fully made up my mind on yet. Intuitively, it really appeals because I really like the discoverability of code, and I really like that my IDE can, without having to go and discover another repo, it can show me what I'm coding against and it can give me that support. But on the other hand, once you get to a certain scale, they become challenging even for the IDE, and then they become challenging at every other level as well. And so then you need to start to invest in lots of code to make sure that you're doing your incremental builds and that you're checking out just the right bit because maybe you don't need the whole bit. And so what I've been told, and I believe it, is that monorepos make sense in very, very small companies because you just haven't got that much code. And they make sense in very, very large companies because then you can afford that platform team whose whole job is making clever tooling to make the monorepo not a nightmare. But in the sort of the middle-sized teams, monorepo, you can't invest enough in it to make it work in a way that's pleasing.
How do you see that practice of like deploying a piece and then just a route some traffic to it, and then potentially you can route back traffic to some other microservice and so on? There we come to that element when there is just a new piece of infrastructure that has to be in place and understood by the developers that wasn't around in the monolith world.
I think it's really important. I think you're right that each piece of this sort of adds a little bit of complexity and it adds a little bit of cognitive load that we didn't have to worry about. But they're all so valuable. So I think in an ideal world, you'd have your unit test, your contract test, your integration tests. And then, as you say, you'd also have all of that observability. So you'd have some feature flags, launch darkly or something else to be making sure that you've decoupled the process of deploying something from the process of releasing something so that you can deploy really, really, really often because a deploy has zero side effects. And then you can also have a lot more control over your releases so that you have those canary tests, those A/B tests, so that you can just start to get a little bit of your traffic going to whatever it is that's new and build up that confidence before you do the big bang. And your success rate is going to be so much higher when you do it that way that it is worth the investment, but it is an investment.
There are companies that, just have 10, 15-year-old monoliths, which maybe don't work great, but they run the business definitely, successfully. And people want to solve many different problems with, moving to microservices architecture. that journey cannot be, very quick, because obviously millions of hours have been invested in that monolith, and, just chopping it up is not really an option. So any advices for the teams that want to do that and are very attractive to going that route?
We all sort of dislike legacy code, and in our industry, legacy code, sometimes it's the code that we wrote last week. And I had that actually. I was working with a team, and we did end up, sort of one of the other developers on the team was sort of having this conversation about legacy code, and all of the other developers turned to him and said, "But we wrote that 3 months ago." I'm really, really sad to hear this described as legacy code. But really, the legacy, it's partly about the age, but it's also about, does it stop you doing what you want to do? And if it stops you doing what you want to do, then you should be looking to change it. And on the other hand, even if it's old, even if it's grotty, even if it's unfashionable, if it's not actually stopping you doing what you want to do, then maybe you should leave well enough alone and focus on things that maybe are less satisfying but more productive. And I think when we look at those sort of big old systems, often we can make that distinction. So some parts of the system probably don't change very often. And so even if we hate them, we probably shouldn't be spending the time to rewrite them, because there's a risk with that and the reward is going to be low. Whereas other parts of the system are probably causing us daily misery. And every time we have to change it, it's so expensive, it's so painful. So if we can divide it on the sort of the painometer, and then try and just carve out the bits that we change most often, modernize those bits, and then leave that connection to the old icky core for the things that changed.
And in the area of just slow feedback loop for developers and developer experience, can you describe maybe, in more detail with Quarkus, what are some of the challenges, and maybe what are just some thoughts? How will you resolve it? Or with some of the projects that you have worked on historically, dealing with just long pipelines and slow feedback loop for developers?
Yeah, with the test, it's really sort of hard to describe what makes a good test. Because as you say, if a test never fails, then that's clearly not a very valuable test. And if a test fails all the time, then it's probably not a valuable test. And so you end up in this sort of like Goldilocks sweet spot of like, well, I really like the test to fail some of the time, but not too often. And then you sort of think, how, what does that mean? But I think probably that, the sort of one of the first things to look at is as you said, because you're supposed to regularly go through and do the exercise of getting rid of tests that you don't think are adding value because they never fail. But I find that really, really painful, because, you wrote it, you invested in it, you loved it, a few years ago, it was maybe a really useful test. And so I think what can be a sort of a psychologically easier is to take those tests and run them less frequently. So you still have that absolute back, safety net of like, okay, well, what if this did fail? What if we were being complacent when we thought it wasn't failing? So you run it overnight or that kind of thing. So you're trying to sort of optimize your feedback so that the feedback is fast, but also the most valuable feedback is the fastest feedback.
Yeah. And I forgot the guest, but someone shared that he was like on a testing conference, and it felt that 80% of the talks are about flaky tests, flaky test detection, and dealing with those. Some of your experiences and like best practices with dealing with those.
Oh, I wish flaky tests are something that I still haven't resolved. And I feel like I keep being optimistic that, maybe in 5 years, maybe we'll have the right tooling, because it does seem like it's something that we could do a much better job with than we do. Like, I'd love to see some tooling in the pipeline that, because you now see tooling that will rerun a test. And so it says, okay, well, I know this test is kind of flaky, so let's rerun it a few times. But I'd love to see that tooling just being more automatic and more widespread, and producing just a bit more of a report at the end to say, okay, so here's your test results. These ones are intermittent and the failure rate is 50%. These ones are intermittent and the failure rate is 5%. Because that's really useful for you to know when you're trying to debug it locally. You need to know, okay, if I run it once, is that okay? Or do I have to run it 20 times to know that I've resolved the flakiness? Or do I have to run it 100 times to know I've resolved the flakiness? And then to try and figure out some of the conditions as well that might be causing it. Like, well, okay, if we run it on this hardware, it's flaky, and on this hardware, it's not. I've been seeing some, just sort of going back to the fast feedback as well. I haven't dug into it yet, but one of the things that Quarkus does, because they're sort of trying to address two needs. So one is the sort of the performance characteristics of your workload in cloud, where you want it to be as dense as possible. But the other one is the developer experience. And so they're doing a bunch of things to do. So for example, they do hot reload so that the dev experience is really quick. And when I joined, I said, but hot reload isn't old. My old team in Webster Liberty did hot reload. And this is sort of a hotter reload. I haven't, because I've only been there for 6 weeks. So I haven't fully looked at the code, but it reloads it much more dynamically. But then one of the other things that they're doing is they've got this sort of idea of continuous testing, which again is sort of, we've seen that before, but it's continuous error testing, and it is using the fact that it hooks into the JVM, and so it does actually know what tests are affected by the code that you're changing now. So it can do that really selective rerunning of just the tests that are likely to be affected, and that if you can do that, then that I think is quite a good thing to do, and potentially safer than something like deleting tests, because in that example of the test that only fails every 3 years, and it's because that code was only changed every 3 years. If you happen to be the person who goes in and changes that code, you still do want those tests to be there, because some tests never fail because they're badly written tests. And, the circumstances under which the tests could fail are basically zero. But some tests fail, as you say, because the code doesn't change very often. And so then those tests, you do need them there, but you need them to be run only occasionally, either by just doing something simple like saying, well, we only run them overnight, or by doing something smart to say, okay, we know what could make this test fail, and it's not the change you just did, so we won't run the tests.
That reminds me about, as you were already talking about the test and what's the confidence that they are, bringing, and what's the value. Any thoughts on the, testing pyramid, and, how to really maintain the test suite so that you have that small number of like end-to-end integration tests that are, slow but very valuable and test a lot of things, and then having a lot of those unit tests. I'm asking primarily because in practice, that really rarely ends up being the case. So I wanted to kind of compare my data with the data that you have.
Yeah, I think you're right. I think there's, in some pathological things, I've seen no integration tests, which wasn't ideal, because then, defects were escaping to the field. And in other times, I've seen too many integration tests. The contract tests are sort of a middle layer in that pyramid. And so I think they're definitely really helpful for trying to sort of maintain the shape of the test pyramid. But they're not very widely adopted. But I think certainly one of the things that I always try and do in my team is, if something escapes to the field, then we kind of want to look back and say, okay, well, why didn't we have a test for this? And let's reproduce it with a test before we do the fix. And then as well, if something fails in the integration test, then I want to know, okay, well, why did this escape to the integration test layer? Why didn't we have the unit test that caught it? And sometimes the answer is, look, this is just one of those things that would only turn up in the integration test. But sometimes actually we could have spotted it in the unit tests, and we just, something was a bit wrong with our testing technique.
And that sounds like, as you said, something escapes. The most natural things that comes to mind is, let's write a test that will simulate exactly that and will catch that, and then we'll have a red test, then we're going to make a green test. But I think that also what ends up being the case is that test that you write because that's the way that you think and that people use your software, is more on that integration level. And then that top part of the pyramid ends up getting fatter and fatter over time with those kind of cases. But as maybe that test is implemented, it's worth the investment. Okay, can we still get the same level of confidence and value and remove that integration test, or let's say replace it with some, faster unit test or contract test or something like that? Yeah.
Yeah, I think that's exactly right. Like when we're developing just in our normal course, but also in code reviews, we should always be asking that question of, can this be pushed down? And when a test is read, in a way, it's a bad time to be looking at pushing things down, because sometimes we're in a bit of trouble and we need to get the fix out now. And we're really proud of ourselves for writing a test at all. But it's also if the red test is when we will have the most confidence to be able to push it down, to say, okay, so I've got this red integration test. Let me see if I can get a red unit test as well. And if I have that, then that gives me confidence to maybe get rid of the integration test, or if nothing else, not propagate the integration test and make it multiply more than it already is.
Well, thank you. These were very interesting, a lot of word stories that we have heard here. For people that want to learn more about your work, current and also previous work, where they can find more about you and, about your schedule regarding talks or,
Yeah, so there's a few places. So I spend too much time on Twitter. So you can find me on Twitter at Holly_Cummins. And I've got a website as well, so hollycummins.com. And that's got links to all of my blogs and podcasts. And we'll have a link to this one. And then it's also got upcoming talks and past talks and that kind of thing. So that's probably the
Great.
sort of the best one-stop shop.
Thanks for sharing all this with us. And yeah, good luck.
Thank you very much.
Microservices architecture is all the rage these days. But do you know what it really means and how to implement it to empower your teams to make the best decision for the problem at hand? On the Semaphore blog, you can learn about microservices and how to take advantage of features like test reports, monorepo, and Docker support to build, test, and deploy your microservice application at scale. Head over to semaphoreCI.com/blog for more information. And happy reading!